Imagine a world where the familiar rules of physics no longer apply. A world where objects can be in two places at once, where particles behave like waves and information travels instantly across vast distances. This is the fascinating realm of quantum theory. This is the story of the universe in its most fundamental form, a story filled with mind-boggling concepts and profound implications. Are you ready to take a peek into the quantum world? In the early 20th century, physicists made a startling discovery. They found that the behavior of particles at the atomic and subatomic levels was completely different from anything they had ever seen before. This was a time of great curiosity and experimentation as scientists delved deeper into the mysteries of the universe. The world of atoms and subatomic particles didn't follow the rules of classical physics laid down by Newton and others. Instead, these tiny particles seemed to exist in multiple states at once, and their exact position and momentum could not be determined simultaneously. This was a radical departure from the deterministic world of classical physics. A new theory was needed to explain the strange behavior of the very small. This led to the development of quantum mechanics, a branch of physics that deals with the behavior of particles on the atomic and subatomic scales. Theoretical physicists like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger were at the forefront of this revolutionary field, proposing new ideas and mathematical frameworks to make sense of the quantum world. This marked the birth of quantum theory. It was a groundbreaking moment in the history of science as it provided a new way of understanding the fundamental nature of reality. Quantum theory introduced concepts such as wave-particle duality, quantum entanglement, and the uncertainty principle, which challenged our traditional notions of how the universe operates. Quantum theory has revolutionized our understanding of the universe. It has revealed that the universe is far more complex and interconnected than we ever imagined. The implications of quantum mechanics extend beyond the microscopic world, influencing our understanding of cosmology, black holes, and the very fabric of space-time itself. It has given us insights into the nature of light, matter, and the fundamental forces of nature. Quantum mechanics has shown that particles can behave both as particles and waves, and that they can be entangled across vast distances, instantaneously affecting each other. This has profound implications for our understanding of the universe and the nature of reality, and it has led to groundbreaking technologies like lasers, transistors, and the promise of quantum computers. These advancements have transformed our world, enabling everything from modern electronics to advanced medical imaging. The potential of quantum computing in particular holds the promise of solving complex problems that are currently beyond the reach of classical computers, opening up new frontiers in science and technology. Let's start with the basics. Quantum mechanics is a fundamental theory in physics that describes nature at the smallest scales of energy levels of atoms and subatomic particles. It's a fascinating and complex field that has puzzled and intrigued scientists for over a century. What exactly is a quantum? The term quantum comes from the Latin word for how much. It refers to the smallest possible discrete unit of any physical property, like energy or matter. A quantum is the smallest possible unit of something. Imagine it as the tiniest building block that makes up everything around us. Just as a single drop of water is a tiny part of the ocean, a quantum is a tiny part of the universe. Think of it like the smallest drop of water you can have. This drop is indivisible in the context of quantum mechanics, meaning it cannot be broken down into smaller parts without losing its essential properties. In the quantum world, energy, momentum, and other physical quantities come in these discrete packets. These packets are called quanta, and they are the fundamental units that make up the fabric of our universe. They are not continuous like we experience in our everyday world. In our macroscopic world, things appear to flow smoothly and continuously, like water in a river. But at the quantum level, everything is quantized, meaning it exists in specific, discrete amounts. Then we have particles, the tiny building blocks of matter. These particles include electrons, protons, and neutrons, which combine to form atoms and molecules, the basic units of chemical elements. But in the quantum world, particles don't always behave like tiny billiard balls. Unlike the predictable motion of billiard balls on a table, quantum particles can exist in multiple states at once and can be in different places simultaneously. Sometimes they act like waves, spread out over space. This wave-like behavior is one of the most intriguing aspects of quantum mechanics and is essential for understanding phenomena like interference and diffraction. This is called particle-wave duality, one of the most mind-bending concepts in quantum theory. It suggests that every particle or quantum entity can be described as either a particle or a wave, depending on how it is observed. This duality is at the heart of many quantum phenomena and challenges our classical understanding of the universe. One of the most famous illustrations of quantum weirdness is Schrödinger's cat. This thought experiment, proposed by the Austrian physicist Erwin Schrödinger in 1935, was designed to illustrate the strange and counterintuitive nature of quantum mechanics. Schrödinger's cat has since become a staple in discussions about quantum theory, often used to explain the concept of superposition in a more tangible way. Imagine a cat in a box with a device that has a 50% chance of releasing a deadly poison. This device is triggered by the decay of a radioactive atom which, according to quantum mechanics, is in a superposition of decayed and undecayed states. Therefore, the cat is simultaneously alive and dead until someone opens the box and observes the system. According to quantum theory, until we open the box, the cat is both alive and dead at the same time. This paradoxical situation arises because, in the quantum world, particles can exist in multiple states at once. It's only when we measure or observe the system that it chooses a definite state. This is known as the collapse of the wave function. This thought experiment highlights the concept of superposition, where a quantum system exists in multiple states simultaneously until it is measured. Superposition is a fundamental principle of quantum mechanics, and is what allows particles to be in a state of uncertainty. This principle is not just theoretical, it has been observed in numerous experiments with particles such as electrons and photons. Another bizarre phenomenon is quantum entanglement. Entanglement occurs when two particles become linked in such a way that the state of one particle is directly related to the state of the other, no matter the distance between them. This means that a change in the state of one particle will instantaneously affect the state of the other, even if they are light years apart. Imagine two particles linked in such a way that knowing the state of one instantly tells you the state of the other, no matter how far apart they are. This instantaneous connection between entangled particles defies our classical understanding of space and time, suggesting that information can be transmitted faster than the speed of light, which challenges Einstein's theory of relativity. This spooky action at a distance, as Einstein called it, has been experimentally verified and has profound implications for our understanding of the universe. Quantum entanglement is not just a theoretical curiosity, it has practical applications in emerging technologies such as quantum computing and quantum cryptography. These technologies promise to revolutionize fields like information security and computational power, leveraging the unique properties of quantum mechanics to achieve feats that are impossible with classical systems. Quantum theory might seem abstract, but it has very real applications in our lives. Lasers, used in everything from barcode scanners to medical equipment, are based on quantum principles. Your smartphone and computer wouldn't exist without transistors, which rely on the quantum nature of electrons. And then there's the exciting field of quantum computing. Quantum computers leverage the principles of superposition and entanglement to perform calculations that are impossible for even the most powerful classical computers. This technology has the potential to revolutionize fields like medicine, materials science, and artificial intelligence. The quantum horizon, a universe yet to be unveiled. Quantum theory has answered many questions about the universe, but it has also opened up new mysteries. We are still grappling with the implications of concepts like superposition and entanglement, and the search for a unified theory that combines quantum mechanics with Einstein's theory of gravity remains one of the biggest challenges in modern physics. The journey into the quantum realm is just beginning. With each new discovery, we are getting closer to unraveling the secrets of the universe at its most fundamental level. Beyond the textbook quantum paradoxes and philosophical implications, quantum theory is not just about equations and experiments, it challenges our very understanding of reality. The idea that an object can be in multiple states at once, or that two particles can be instantaneously connected across vast distances, seems to contradict our everyday experience. These quantum paradoxes have sparked countless debates among physicists and philosophers alike. They force us to confront fundamental questions about the nature of reality, the role of the observer, and the limits of human knowledge. Quantum physics for everyone. Quantum theory may seem like a daunting subject, but it's a journey worth taking. It's a journey into the heart of reality, a journey that will challenge your assumptions and expand your horizons. There are many excellent resources available for anyone interested in learning more about quantum theory, from popular science books to online courses and lectures. Join the quantum conversation. So, what do you think about quantum theory? Does it blow your mind? Do you have any burning questions about the quantum world? Share your thoughts and questions in the comments below. And don't forget to like and subscribe for more mind-expanding content.